Okay, so now we're going to cover the Earth's spheres. So, as I said, our planet is a dynamic body with many interacting spheres or parts to it. The four parts that we're going to cover here within the Earth's spheres are going to be the atmosphere, the hydrosphere, the geosphere, and the biosphere. And although all of these spheres can be studied separately, they're not isolated and they are constantly interacting with one another. So in fact, when we look at photos of the Earth from space, we realize how amazing and how complex our home is. It is a lot more than just rock and soil. And in these pictures, one of the striking features that we see is the amount of cloud cover, for example. And that represents the importance of water in our planet. So it's actually kind of curious that before satellite pictures, we thought that the Earth from above looked as though there were no clouds. So we just thought it was mostly the rock and soil and the continents and then the water and the oceans. We didn't think that the cloud cover could be seen from space. So that was one of the surprises that we came up or we encountered once we started getting pictures from space. Okay, so we're going to cover each sphere separately now, but it is important again to remember that these spheres are constantly interacting. So the hydrosphere is the first one we're going to cover, and it represents all the water contained in our planet in all its forms. So those forms being gaseous, liquid, or solid forms, or any forms in between those three. So the largest water body that we have is the ocean, as you know, and it covers about 71% of the surface of the Earth. It represents about 96.5% of all of the water in the world. The remaining 3.5% of the water is spread throughout as either saline groundwater and lakes, which accounts for 0.9%, or fresh water, which accounts for 2.5% or so. The fresh water itself, as you're seeing there in the subdivision, is spread between glaciers, which is the greatest amount of groundwater, or the greatest amount of fresh water, and it accounts for 1.72% of the total water on the planet. And as you can see, the largest storing body of fresh water is these glaciers. In groundwater, which is the second largest storing freshwater reservoir, if you would, we have 0.75% of the total water. And then the remaining amount of water, which really is only 0.03%, is subdivided between lakes, streams, soil moisture, or even atmospheric water. So by atmospheric water, I mean things like clouds, hail, snow, rain, and whatnot. So even though fresh water is so limited, it is incredibly important for life on land. So we have to be very conscious of how we are using this fresh water and how we can maintain it to be and continue to be useful to all life on Earth. All right, so the second sphere is going to be the atmosphere. So it is a gaseous kind of envelope, a thin layer, if you compare it to all of the Earth's radius or diameter, I guess. So this gaseous envelope of gases surrounds the Earth and make it possible for living organisms to continue to live there by having just the right mixture and gas mixture content for us to breathe, and by protecting us against the sun's heat and the UV radiation. So as a comparison, the temperature on Earth's surface varies between 10 to 15 degrees Celsius depending on whether the sun is hitting it or not. So again, if you're in the shade, you get 10 to 15 degrees Celsius lower temperatures than you would if the sun is hitting it. The temperatures in the moon surface, where there is no atmosphere, range about 250 degrees Celsius depending on whether the sun is hitting it or not. So our atmosphere is protecting us from extremely hot or extremely cold temperatures from the sun, as well as protecting us from UV radiation. So that is one of the amazing things that the atmosphere has to give us, as well as providing us just the right mixture of gases that help us breathe and help all the other species develop the way they have. So this exchange of energy that continually occurs between the atmosphere and the Earth's surface and the atmosphere and with space produces the effects that we call weather and climate. So climate will have a large influence on the nature and intensity of Earth's external processes. When the climate changes, these processes will respond. So again, weather and climate differ because weather is at a particular time. Climate tends to be a longer time span. So say, I don't know, decades to centuries. You cannot say that there is a climate change if you see this winter being colder than last one, for example. But if you see a trend over the last 20 years, perhaps, it might be safer to say that there is. So, yeah, atmosphere incredibly important, and it responds to these changes and the exchanges between the Earth's surface and also with space. Okay, so the third sphere here is the biosphere, and it contains all life. So ocean life is concentrated for the most part in the sunlit upper waters, which are going to be the depths of up to 200 meters or so. So most of the life on land is also concentrated near the surface, with just a few organisms specialized in flying just a few kilometers above the surface, but eventually returning to the surface, right? And some organisms specialized in burrowing underneath the soil cover. But for the most part, life, both in the continents and in the oceans, relies on areas near the surface. There are some organisms that have specialized in incredibly deep and incredibly dark environments of the ocean floor. Some other organisms that are thermophilic, which means heat lovers, that specialize in being near hot springs. And some other bacteria that go about 4 kilometers in depth, which also turn to be a little bit thermophilic. Some other life is carried many kilometers above the surface by wind currents. So somewhere in the atmosphere, it's carried up in wind currents. But for the most part, life is mostly confined, as I said, to this narrow band near the Earth's surface. So life is a key factor within the interaction of the spheres, of the other 3 spheres, through countless interactions that help maintain and alter the physical environment that life is in. No, let me correct this real fast. Lastly, the last sphere that we have here is the geosphere. So beneath the atmosphere and the oceans lies this geosphere, or solid Earth. It extends from the surface to the center of the Earth. So it goes all the way to about 6,400 kilometers in depth. So it's definitely the largest sphere that we have in terms of volume. Because of accessibility problems, most of the studies of the geosphere deal with surface or near-surface features. And thankfully, by examining the most prominent surface features and their global extent, we can obtain clues to what is going on underneath. All the major forces that have shaped our planet tell us this by those surface features, or for the most part. Soil, as you can imagine, is a mixture of all of the 4 spheres. In soil, you find partly rock, you find moisture within the soil, so that being the hydrosphere component. You find air spaces, pore spaces, that being the atmosphere component, and those pore spaces also have different gas mixtures within them. And you have also life making up what we call soil, so that being the organic matter within it. So you'll see soil again is a mixture of all the 4 spheres that we have. And we will cover soil in a much deeper way when we go through chapter 6.